did it, it said find all the critical points and then the relative, or the and extrema for blah, blah, blah. And you needed a trig identity. Oh, that doesn't look like I totally finished mine. So it's like, alright, so just kind of like refresh you a little bit. What we did on Thursday was we looked at functions and we decided, or we were trying to find where they had maxes and where they had mins. See, you're so gross. I don't even know. You see his like big tongue sticking out.
He's just thinking of me.
I'll do it like when we have more to check, because it's just the two things right now. Most people didn't even realize there was an assignment on Friday. So the assignment on Thursday night was just to take this function and figure out where it had maxes and mins. They give you a closed interval, which right now is kind of all you really know how to do until tomorrow. We'll open it up and it'll be on the whole number line, all real numbers. So what you should have done for this was take the derivative. I did not use any identity until I took a derivative. So I took a derivative, I got 2 cosine x minus 2 plus 2 sine x, 2x. And the idea is you're trying to figure out where this thing equals 0 or is undefined. Is this ever going to be undefined?
No.
No. Okay, it's not a fraction. I don't have anything in the denominator that's a variable, so it can't be undefined, at least with just the trig function. So it's not going to be undefined, it's just going to be 0. To solve this for 0 without a calculator, you needed a trig identity. And I had to look it up. I don't expect you to remember them, other than the Pythagorean triples. I replaced the sine of 2x with 2 cosine x sine x. Okay, so that was the trig identity. You could have looked it up in somewhere. I don't know. Last year's notes, the book probably has it somewhere. Google. And now I'm solving for 0. So this is a tricky thing. What I would do is take out probably a 2 cosine x. I'd be left with 1 here plus a 2 sine x. 0. Do you understand what I did? I'm kind of multiplying this 2 by this, and then I'm taking a 2 out and a cosine x out. So I have two things. I have 2 cosine x equals 0, basically the cosine of x equals 0, and I have the sine of x equals negative 1/2. Bring the 1 over, divide by 2. I'm on the interval 0 to 2 pi. So I don't have to have any like plus pi 2k's or anything. I just have to list the x values that make cosine 0 are pi over 2 and 3 pi over 2. And the values that make the sine equal to negative 1/2 are, I looked, 7 pi over 6 and 11 pi over 6. Understand what I did so far?
Yep.
Take a derivative, set it equal to 0, solve it. Okay, from here to find out where the maxes and mins are, I got to make it a huge, annoying number line because I need to include the endpoints, so 0 and 2 pi, and I have to include every single critical value. And they've got to get plugged into the original function to figure out what the y values are. So I'll just tell you what they are. I got 0, negative 1, 2 pi, negative 1, pi over 2, 3. This is negative 1, negative 3/2, and negative 3/2. So when you have a closed interval, you can say definitively, here's where my max is, my absolute max. You might have more than one, but they both have the same y value. And where's my absolute min? Could have more than one, but they'd have the same y value. So my biggest y gets me my max, so that's here. So I have a max at pi over 2, comma 3. And as far as a min goes, negative 3/2 is my smallest y, and it does happen twice. So 7 pi over 6, negative 3/2, and 11 pi over 6, negative 3/2.
Why do you have pi?
Oops, don't know why. it's just a really mechanical thing at this point. You're just going through the motions a little bit. But it should make sense that your mins and maxes can only happen where a derivative is 0 or undefined. It's where there's a nice smooth peak or valley, or where the derivative is undefined, you got the cusps in the corners. So I find those spots, and then I look at those and the endpoints to see which is my absolute max or my absolute min. If it didn't have that interval, and it asked you to find all the relative extrema, we wouldn't worry about the endpoints, and we would just find all of these and say these are mins and maxes, and we don't know which is which yet. Tomorrow we'll start to know which is a min, which is a max. Okay, any questions? All right, Friday, it sounds like people have a couple questions, but not everyone even knew about it. So I'd like to maybe wait to go over Friday's homework tomorrow. It's up there. There's just 4. If you were absent Friday, sorry, that means it's going to be like double for you tonight, but it'll be good for you. Puts hair on your chest. And we have a little bit of notes to do. So who gave blood today? Nice. Good job.
You didn't do double right? I'm too tiny. Too small. They wouldn't let me. You're too small. Yeah.
Oh, it's so precious.
Thanks.
What type are you?
What?
What type? They don't tell you that.
ABO. Positive.
Oliver, how do you know what type you are?
What?
How do you know what
I
type
think
you
I'm
are?
A
They
negative.
tell you.
They do not tell you.
You'll get a blood donor card in a couple months.
She told me. Oh, because I did last year.
I did it last year too.
Oh,
They never told me.
What are you?
Oh, positive.
Lane.
Lean? How can you be lean?
That's the most
Blood type.
common. I'm like A negative.
What are you?
What are you?
I don't know.
It's like
Still a little.
a couple in terms of
My
people.
blood.
It's
Red
red
gold.
gold.
It's coated
People are dating
And look, apparently you can only do double if you have positive.
No, it's
Really?
O negative.
Why?
I don't know, because she was like, you're
positive.
no,
Like I'm
negative
right.
universal.
Yeah, so
I
why would they
guess
want double
universal.
negative?
I don't know, it must be something to do with your blood. Because she told me, she was like, you're O positive, so you could do double since you're positive.
You doubled? Yeah, that's alright.
How many?
You feel better after double.
your blood type?
She told me.
Yeah, they never gave me my plasma.
I don't know.
Doesn't have.
Yeah, I know.
Nuke
Why?
has maple syrup.
My plasma.
Feel worse.
Alright, so there's not many theorems in calc that you have to like know or remember, but these two you do.
Wait, does that mean that we don't, never mind. Identity doesn't count.
No, like theorems are like big main rules that you actually have to identify by name usually or whatever. So like Rolle's theorem, so Rolle's theorem is as important as Euclid's theorem does come up. So anyway, Rolle's theorem was discovered by this guy named Michel.
Milo.
Oh.
Wait, isn't that the last name is Roll, not Rolls?
His last name is Rolle.
Okay.
Michel Rolle. He was some French guy.
Doesn't sound
Doesn't sound what? No, I know. Usually you hear like Rolle's theorem and you would tune out, but try not to. So the basic concept of Rolle's theorem is very easy. What he said is, if a function is continuous and differentiable on some interval, a closed interval. So in other words, it's got no goofy stuff happening, it's just nice and continuous. And f of a, so say you have some interval from a to b. If the y value at a is equal to the y value at b, then somewhere along the way, the derivative has to be 0. That's Rolle's theorem, yeah.
That's stupid.
Yeah. So he just said,
Wasn't it?
I'll write it down officially, but if we have some interval from A to B, and we have a curve that's continuous and differentiable on that interval, and the y values where I start and the y value where I end are equal, then somewhere in between here, the derivative has to be 0. Which is kind of obvious, right? So if this is f of a and it's also f of b, so my function starts here and it ends at the same y value but over at b, and if this is continuous and differentiable all throughout, then somewhere, at least once, there's got to be a spot where the derivative equals 0. In this case, it's happening there, and it's happening there. Blah, blah. Who cares? Okay, so it just says if f is continuous and differentiable on the interval from a to b, it's closed. It's got to be closed, or it doesn't work.
So why do I care?
We don't really. We care a little bit more because it goes into the mean value theorem. Just thinking. The reason why it's kind of important to understand the words of something like this is next year. Zach, what are you doing? When you guys get to college, is anyone planning on majoring in math?
To physics classes.
Or a math, short, business, engineering,
Oh.
physics,
Business counts.
Are there any other real majors?
something math
History.
related.
Ha.
Art.
Arts?
Well, you're
Never-
going to
never
be in a
mind.
math class where you might not understand the professor very well, and you might have to learn a lot from a textbook, and that's really hard. I thought that was some of the, especially math, it's one of the hardest parts, I think. Oops. About math is learning from the textbook, because everything's written, this way, and you have to be able to read that and understand what it means and what they're trying to tell you from that. I thought that was one of the hardest things, and once I got good at that, I had a lot easier time in my math classes. But so this is saying if f is continuous and differentiable on a closed interval, and it's important that it's closed, and f of a equals f of b, this is saying the y values are equal, then there exists at least one value c on AB. So what is c?
Point.
A point. It's not a point totally though. It's just an x value. So c is only an x value. So it's saying there exists at least one value c on this interval AB. So c is along here somewhere. In fact, with my little picture, I have a c here. Let's say c sub 1, and I have another one here, c sub 2. So in my picture, I have two c values that the derivative at c equals 0. This theorem would also work if you just had a horizontal line. If I just was like this, it would still work because then the derivative would be 0 everywhere. And all Rolle's theorem guarantees is that there's at least one value between a and b such that the derivative is 0.
Are there any mins and maxes on that line?
I don't
Or are they
know.
all mins and maxes?
I don't know.
Okay.
I don't know.
Max.
Okay. So, here's what they would say is prove the existence of, or show that the function satisfies Rolle's theorem, blah blah. Do you think you could probably do it if you had to? I'll show you.
Maybe.
Here's one. Let's do everything's going to be very easy.
They're gonna give you ones that aren't differentiable and then be like, JK, you
They,
can't do it.
they could. So let's just say, well, even if they gave you 1 over x, even if they gave you, let's say they give you a function of 1 over x.
Yeah, but that's fine there.
We know it's not differentiable at 0, right? but 0 is not in the interval, so you're like, okay, I'm fine. But what else isn't true that's supposed to be true to meet Rolle's theorem?
The y value.
The y values aren't the same. Okay, so in this one, it is continuous and differentiable on this interval, that's fine. But f of 2 is a half, oops, and f of 4 is a fourth. So since they're not equal, Rolle's theorem doesn't apply. Ours only applies if your y values are equal, which makes sense. If I go graph 1 over x from 2 to 4, there is no spot in between there where the derivative is 0. Well, it's because the y values didn't match to start, so we don't have any guarantee that that would work. Even if, for example, they give you f of x equals 1 over x and you're not thinking about it being differentiable, what if they give you the interval like, oh crap, nothing's going. Well, 1 over x squared, like they give you negative 2 to 2. You might be like, oh wait, f of negative 2 is a fourth, and f of 2 is a fourth. I'm set. It's going to satisfy Rolle's theorem, but it's not because it's not differentiable at 0. They could. Okay, so look out for, is it differentiable or not? And if it's not, don't do it. And then, are the y values equal or not? And if they're not, don't do it. So it's got to satisfy those two things for you to be able to do the problem.
Just ignore the question.
So if you had this one, let's say, I know that this one works. We'll go negative 2 to 2. So it might say, find all values C such that f prime of C equals 0. Oh, find all values C on the interval negative 2 to 2. So sometimes that might be the only instructions you're getting. They might never use the word Rolle's at all. And you're supposed to kind of be like, okay, this should make sense to me, and this is a Rolle's theorem problem without them saying that. They're giving you a closed interval. They're asking you to find when the derivative is 0. So we want to check, is this thing continuous? X to the 4th minus 2x? Yeah, there's no fraction, there's no weird stuff, it's continuous, it's fine, it's differentiable, it's fine. And let's check, what is f of negative 2 and f of 2? Does everyone kind of agree that you don't even really have to plug them in to know that you're going to get the same y value? Why is that? Yeah, because it's an even function, everything's squared, so everything I plug in is going to give me the same result if it's a positive or a negative number for the same number. So I know that these things are going to be equal. I don't have to find out what they are. So find all values C. I got to just take the derivative now. 4x to the 3rd minus 4x. Set it equal to 0 and solve. So my C values are going to be 0 and positive and negative 1. And those are going to be all the spots where the derivative equals 0 on the interval negative 2 to 2. It is possible that when you take the derivative, you get critical values outside of the interval. Don't use them. Okay, they only want to know what C values do you have that are on the interval. If you get stuff that's not, that's fine. You could have mins and maxes elsewhere. They're just wanting to see what, I don't know, I guess what the mins and maxes are in that interval. Okay, is that okay? All right, mean value theorem. So this kind of leads into the mean value theorem. And in its like broad definition or explanation, the mean value theorem basically just says, if I go from point A to point B, it doesn't matter what the y values are. As long as the function is continuous and differentiable along the whole thing, whatever the average rate of change is from A to B, so my average rate of change is like shown by this line. Okay, so like whatever my slope is from one point to the other, from A to B, there's got to be at least one point somewhere along the curve where the instantaneous rate of change was exactly the same as the average rate of change. So in other words, if the average rate of change is shown by this line having this kind of slope, somewhere along this curve, the same slope existed of the tangent line. And it happens here twice. So this line and this line represent the instantaneous rate of change. Which is the derivative. It's kind of like saying, if I drive from here to Atlantic City and my average speed is 40 miles an hour, at least once I was going 40. Do you know what I mean? So if my average rate of change was 40 miles an hour, at least once I had to be going 40. Didn't skip over 40. I didn't go 38 half of the time and 42 half the time without hitting 40 at some point. At least in this universe with a continuous function. Okay, so the idea is it's continuous. You can't hop over values that are your average value. So in fancy terms, this says, oops, that's supposed to be it. If f is continuous and differentiable
Kind of fancy.
on AB, if f is continuous and differentiable on AB, then there exists at least one C on AB such that, here's how this is written. We want to say such that the average rate of change from A to B equals the instantaneous rate of change.
Instantaneous.
Instantaneous.
Insanious.
What that would look like at some value C. I'm sorry. I'm really sloppy. I don't mean to. What it would look like is this. How do I write average rate of change? So let's say this is an f of A, and this y value is f of B. How can I represent what the average rate of change is from A to B? Like, what's the word that describes what the average rate of change is?
Slope.
Slope. So I'm just going to find the slope. I'll take f of B minus f of A. So it's a y value minus a y value over B minus A, x minus x. This is the average rate of change of the function, and the instantaneous rate of the change of the function is f prime at some point C. I'm going to go Monica on you for a second. Oh, that's not Monica.
Aw.
That is really important to become familiar with and comfortable with, because when you see a problem, it's just going to say this. They're going to say, like, find the value, or find C such that the, and this means use the mean value theorem. So I'll show you what it's going to look like. Oh, before you do that, if you stop and think for a second, isn't the mean value theorem the same thing as Rolle's theorem, but broader? Rolle's theorem said if the y values were the same at the beginning and at the end of the interval, then the derivative somewhere was 0. Well, if the y values are the same, what is the average rate of change from one to the other? 0. And so then the instantaneous rate of change somewhere is 0. So the mean value theorem is just a broader way to use Rolle's theorem. Rolle's theorem just says when my two y values are the same somewhere, this is going to be 0. Well, it's the same thing. The slope here is 0, so the average rate of change somewhere is 0.
Which theorem came out first?
I don't know. I'm thinking Rolle's did, but I don't know.
Because I'm thinking, like, if mean value theorem came out first, then Rolle's just copied off of that.
Yeah.
And if Rolle's came out first, then he wasn't working very hard because he didn't figure out the mean value theorem.
Unless he did both, and he just couldn't name both Rolle's theorem.
Well, like the second Rolle's theorem.
Rolls theorem, part 2.
Rolls.
The Michelle
2000
theorem.
with that.
Yeah, 2000.
I'm pretty sure that's what was discovered.
So usually you'll see it like this. It'll say if f of x equals whatever, find all values of c on the interval blah blah such that blah 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 blah. It's not very exciting, but whatever. It's gotta get done. So all I literally have to do is first I'm gonna go find the slope. So I'm gonna find out what is f of 4 minus f of 1 over 4 minus 1. Plugging them into the original function. So if I plug in 4, I get 1, and if I plug in 1, no. Is that right? If I plug in 4, I get 4.
Yes.
If I plug in 1, I get 1. Okay. So I end up getting 4 minus 1 over 4 minus 1, which equals 1. This is the average rate of change. I don't have to write that. I'm just writing it in case you're unsure of what it is. And now I'm going to find the instantaneous rate of change. So I'm going to find the derivative. The derivative of this, you want to start to be able to do this in your head. The derivative of 5 is 0. And negative 4 over x, this is like negative 4x to the negative first. So if I take the derivative, it's going to be 4 over x squared. And what am I supposed to do with that? Plug in 1? Equal to 1. Okay, I'm not plugging in 1. I didn't find any x value yet. I'm supposed to be finding all the values of c, which might as well say x. So if I plug in 1 for x, I just totally screwed it up. They want to know where does this happen. So where is this equal to 1?
Positive negative 2.
Okay, and that's what I'm solving. Where is it equal to 1? When x equals plus or minus 2. Go back, look at the interval, which is the only one that counts. 2. Therefore, so c equals 2. And it's just kind of helpful to understand what that's talking about. That's talking about a point at 2 comma what?
1.
2 comma 3, right? What this is saying is I have this graph, 5 minus 4 over x. Isn't that just like, it's this asymptote, and then like, does it move up 5?
Yeah.
And it's negative, so it's like in these quadrants perhaps? It's saying between the point 1, hold on,
And it's like skinny.
1, 2, 3, 4, 5. Between the point like 1, 4 and 4, 1, whatever, the slope is this. And at the point 2, 3, the slope is that again. Terrible picture. That's what it's trying to say. So that if I take my 2 endpoints here and here and connect them, between there, at 2, 3, I have a tangent line with that same slope.
Straight lines.
What?
Straight lines.
What else are there?
Those are straight lines.
Yeah.
You're very straight lines. They're so close, so straight.
You're saying that I did a really good job?
Those lines. The rest of it.
On the table.
I'm not listening to you.
I think that.
Okay, that's it. That's it. So the homework?
We have enough time.
I'm so good.
Alright, so homework page 192.
Number 1. It's like the lottery and you're playing pick 3.
That one?
Yeah.
184.